Okay, well, let us go ahead and go over the homework problems. And you'll notice in these homework problems, okay, we're going to try to find the horizontal asymptotes at them, okay? Now, in order to do that, again, we just focus on the highest degree on the numerator and denominator. And right here, I know the 4x squared is the highest degree, and I notice that x squared is the highest degree. All right, so I know the limit as x approaches infinity. Well, we're just focusing on the highest degree on the numerator and the bottom. The x squareds cancel out and we just get 4. Wow, very, very simple, right? Our answer is just 4. That's pretty nice. Let's go ahead and look at this next problem. Oh, the horizontal asymptote equation, of course, that's going to be y is equal to 4 then. Okay. That means that when our function approaches infinity, right, however it behaves, I don't know how it's going to look like, but this is 4, and maybe it's going to do something like this and just get closer and closer to 4. Okay. Maybe something like this right here. I don't know, however you want to look at it. And it's going to approach that line right here, which is y is equal to 4. Okay, let's go to problem number 2. Well, we do the same thing as x approaches infinity. Oh, whoops. It's the exact same problem. It looks like I put the exact same problem as before. No, I didn't. Okay. I fell for my own trap that I put on this problem. And you look, the trap is, I thought it was 4x squared and x squared, right? Well, no, the highest degree is in the middle, is x to the 4th. It snuck up on me. So we're going to get x to the 4th, well, divided by x squared. Well, this is 4x's on top, 2 on the bottom, they cancel out, and we're just going to get x squared over 1. And as I plug in infinity, well, it's going to be a big number, it's huge squared, which is just still huge. Right, it keeps going to infinity. So, well, our y values then is non-existent, and the horizontal plane is not applicable. It does not exist. Okay. All right, let the function f be given by f of x, and we have this function here. If the line y equals b is a horizontal asymptote to the graph, then b is, well, we're just trying to find the horizontal asymptote, right? And we're trying to determine, okay, if our function does something, if it goes like this or like that, or maybe it's down here at 0 and it's going to go down, and it's going to go down like that. And we're just trying to figure it out. So in order to do that, we focus on the highest degree numerators and the highest degree denominators. But you notice we do run into what I will call a problem, because right now it's in factored form. And when we want to do this, we want it to be in full, we want to see it out when it's, I guess you could say, general form. So first, let me just write it down over here. So in order for us to solve this problem, you see the square, the 2x minus 1 squared means we have 2 factors on the bottom of 2x minus 1. And when we're trying to find horizontal asymptotes, we're always asking for the end behavior, all right? Well, in order to do this problem, I'm just going to focus on what's going to give me the biggest degree on the numerators for the x's. Well, 2x times 4x is going to give me 8x squared. And I can ignore the rest because I'm not going to get anything higher than x squared. Now I do the same thing down below here. Well, 2x times 2x is going to give me 4x squared. And these cancel. I get 8 over 4, which in fact gives me 2. Which in fact gives me 2. Therefore, I can conclude C is my answer. All right, let's go ahead and look at this problem here. It says we have this graph and we have this equation given to us, and we want to see what could be the values of a and b. So we have this graph here, f of x is equal to ax squared minus 30, all divided by x squared plus b. And we want to find the limit as, well, first of all, if you look over here, according to the graph, the horizontal asymptote, right, the horizontal asymptote is 4. Okay, so we know the horizontal asymptote is 4. This is, I would say, our horizontal asymptote. And I know my vertical asymptote, which is right there. Okay, my vertical asymptote is x is equal to 3. And this is my vertical asymptote. All right, so if I want to find, okay, my horizontal asymptote, that means when I take the limit as x approaches infinity, we focus on the highest degree numerators, which is ax squared. So we're going to get ax squared divided by, well, x squared, and these cancels out and we're left with a. Well, then what does a have to be? Well, in order for it to be 4, a has to equal 4. Okay, so I can conclude so far that we're going to get 4x squared minus 30, all divided by x squared plus b. Okay. Sorry about that if you hear that in the background. That's just my puppy having a dream. Okay, if we want to find our vertical asymptotes, what that means is we need to get on the denominator. If I plug in 3 into my denominator, I'm going to get 3 squared, which is 9. So I'm going to get 9 plus b. And this should equal 0, right? I should get 0 here because when I plug in 3 on the denominator, I should get 0. So what does b have to be? Well, b has to be negative 9. 9 minus 9 is 0. Therefore, I can conclude that b has to be, all right, negative 9. All right, if I wanted to, what I could have also done here, well, that's pretty much the best way for you to go about it, okay? So now we know that our equation is going to be 4x squared minus 30, all divided by x squared minus 9, okay? We can verify this. If I took the limit as x approaches infinity, well, I'm going to get 4x squared divided by x squared, and I'm going to get 4. That makes sense. On the denominator, if I set that equal to 0, I can solve it. And I'm going to get, well, I add 9 to both sides. I set it equal to 0 because that's when it's undefined. And we get x squared is equal to 9. I take the square root. I'm going to get x is equal to plus or minus 3. But you'll notice we only have the positive 3 here, right? The negative 3 is over here, and the graph doesn't show it, and I bet you it also has a vertical asymptote at this location here, all right? But our graph didn't show it, and that's why if you go to verify it, you'll get another solution that the graph doesn't show. So A has to be 4, and B has to be negative 9. I can therefore conclude that my answer has to be C. All right, well, let's go ahead and find the line y equals 6 is the horizontal asymptote to which of the following functions. So the limit, okay, as x approaches infinity, well, I want to focus on the highest degree numerator. Well, it's this right here, negative 12x squared. So I'm going to have negative 12x, to the 10th power, and then 6x to the 10th power. Well, these cancels out, and I'm going to get negative 12 over 6. Negative 12 divided by 6 is negative 2. So we know this does not work. Let's go to this one. We have the limit as x approaches infinity of x squared over x. Well, this is just going to give me x, and that's just going to be some big number as we plug in bigger numbers. So this does not exist. Therefore, we can conclude that one doesn't work. Okay, cosine, this one's kind of tricky, but cosine is just right? Cosine is just a graph that looks like this. It's just circulating between 1 and negative 1. All right, so as I plug in the limit as x approaches infinity, all right, of cosine times 2x divided by x squared, okay, this is going to be some number that isolates between negative 1 and 1. Well, the x squared is going to be really big squared, so essentially I'm going to get bigger and bigger on the denominator, while my numerator values just oscillate between negative 1 and 1. Therefore, this is going to get closer and closer to 0 because it's going to keep getting a bigger and bigger number in the denominator. Well, that's not 6, so we can cancel that out. Shoot, okay. Let's continue on. Let's see what we can do. This last one. Well, look, the factors, these are already the same. We can cancel them out. And we have 3 divided by 0.5, all right, which is the same thing, right? 3 divided by 0.5 is 6. That's perfect. All right, so the limit as x approaches infinity of this function here, 3x to the third divided by 0.5x to the third, is going to give me 6. Okay, if you're wondering why 3 divided by 0.5 gives me 6, well, I'll write it over here. This is 3 divided by 1/2. Do we agree? 1/2 is the same thing as 0.5. Well, 3 divided by 1/2. And then now to turn it to a multiplication problem, I have to flip. All right, I should say take the reciprocal. And so we're going to get 6 divided by 1, which is 6. Okay, so this problem down below over here is asking us to write down, well, what is the horizontal asymptotes? Well, for A, it's y equals negative 2. For B, it does not exist. For C, it's 0. Okay, and for 6, well, that one did satisfy the equation above, so I'm not going to need to do that one down below. All right, well, that's all the problems for today. You go ahead and have yourself a great